Hey Geometry, we are doing lesson 16 today, which is translations. Another word that we can use for translations is called a slide. So you just take something and you're sliding it along. Okay, that's what a translation is. We're not rotating it, we're not reflecting it, we are just sliding something. And it always goes in a direction and a distance. That would be our slide. Alright, the next thing we're going to do, actually the first thing we're going to do is the exploratory challenge. You have your drawing and the instructions on the same sheet. I'm just going to move this in a second. So in lesson 4, you completed a construction exercise that resulted in a pair of parallel lines, which is problem 1 from the problem set. Now we examine an alternate construction. We're going to construct a line parallel to a given line AB through a given point P. So I'm going to move this a little bit. You have your instructions though, you don't need mine. I've already got some drawing on here. I messed up the first video, so I had to erase it and start over. And I drew with marker, so it was hard to start over. So let's follow the instructions. First I'm going to draw a circle P with center P, radius AB. So let's get our radius set. There we go. So circle P, radius AB, my bad. Let's get that right. So radius AB with the center P. Just like you guys, sometimes I move my compass. It helps if you have a stack of papers sitting underneath, not just one piece of paper. Cool. So now I'm going to draw a circle B with the center B, radius AP. So I've got my radius AP. Not quite there yet. But I'm going to draw that at B. And it makes perfect sense. There we go. Now it says label the intersection of circle P and circle B as Q. I could have labeled this one, but that's not going to give me a parallel line. So I have to pick the intersection Q so that points A and Q are on opposite half planes of line BP. So I've got one over here and one over there. If I picked this one, they'd be on the same half plane, and that doesn't work. So here is my parallel line. So what we see here is this line is parallel with line L. We just did a slide or a translation of ray AB. So that would be a translation of ray AB. So here's ray PB. Oh goodness. Hopefully you did this in pencil. BP. We're going to use ray AB the rest of the lesson, but this one is BP. So we just moved this line, we translate it, we slid it a direction of BP and a distance of BP. Okay? That gets us into our next slide, which is our discussion. So to perform a translation, we need to use the previous construction. Let us investigate the definition of translation. Okay, we've said it's a slide. Okay, this is very wordy. We're not going to focus as much on this. But we've said a translation is a slide. It's a slide over a vector. And a vector gives us direction and distance. So for any point P on the line AB, translation of ray AB of P is the point Q. So that's the new point. So we're going to translate P, a direction and distance, and make it a Q. Okay? Note the parallel line construction on the previous page shows a quick way to find the point Q in part 2 of the definition of translation, which we're going to get to. So if we look right here, we have this C to C prime is our vector. That is the direction and the distance that we're going to translate this parallelogram onto that parallelogram. And I can draw vectors from each point. So I have B to B prime, A to A prime, D to D prime. Each one of these vectors I drew 4 vectors. They're all the same direction and distance. In the figure to the right, the quadrilateral ABCD has been translated the length and direction of vector C, C prime. Notice that the distance and direction from each vertex to its corresponding vertex on the image are identical to that of C, C prime. And that's what we did right here with all of these vectors. Example 1, draw the vector that defines each translation below. I've already done this, so we went from the solid one to the dashed one. I just picked a point on the pre-image and a point on the image, and we have our vector. Image to pre-image, and that's the direction and the distance that our translation is going to go. This applies to the next slide. Finding the vector is relatively straightforward. Applying a vector to translate a figure is more challenging. To translate a figure, we must construct parallel lines to the vector through the vertices of the original figure, and then find the points on those parallel lines that are the same direction, distance away as given by the vector. So I'm going to draw a circle with P1 as the center, the radius of AB. And the same thing at P2. I moved it. Okay, example 2. Use your compass and straight edge to apply the translation on ray AB, so translation on ray AB to segment P1 and P2. Note, use the steps from the exploratory challenge twice for this question, creating 2 lines parallel to AB, one through P1 and one through P2. So we're going to create 2 lines parallel to ray AB, one through P1 and one through P2. So that's what we're going for. All right, the first thing I'm going to do is draw a circle, the radius of AB, throw away, 1 through P1. Oh, see, it happens to me too. And 1 through P2. Now I can't draw my circles very dark because I just can't use the compass that way. I can't spin it, hold it still, and draw really dark circles. So, all right, the next thing we need to do is a circle, radius PA through B. Okay, it's the same steps we used for the exploratory challenge. And then a circle, radius AP2. The first one was AP1. Now we're doing AP2. You get that radius right. And through B again. So here's our point, and here's our point. And that's going to be our parallel line. And this is going to be our parallel line. So we have our original ray and our 2 parallel lines. Awesome. Okay, the next thing we're going to do is use our compass and straight edge to apply translation from ray AB to triangle points 1, 2, and 3. So we're going to slide this triangle in this direction using this ray of translation. All right, the first thing I'm going to do is find radius AB. And I need 3 circles, one around each one of the points. That lead just got shoved up in there. Ah! Three circles. After I'm done drawing these, I'm going to have to push pause and fix that lid. Okay, hold on a sec. Okay, I think I'm fixed. Okay, now I need to draw a circle with the center B, but radius AP2. I don't have to draw the full circle. Now we're going to do AP3. Okay, your picture is a bit smaller than mine, so you won't have to open up your compass quite so far. And then draw the circle through B. And then AP1. Hopefully my compass goes big enough. AP1 and draw the circle through B. Cool. Now, there are our new points. My straight edge isn't big enough. Let's see. Hopefully I don't mess this one up. Excuse me. Ah. Paper's not the best straight edge. Let me highlight it for you. So you should label your points something new and prime. So you can do P1 prime, P2 prime, P3 prime, or a different letter would work too. Nice job. All right, relevant vocabulary. We've already used the word parallel, but if two lines are parallel, say 2 lines are parallel if they lie in the same plane and do not intersect. They never intersect. 2 segments or rays are parallel if the lines containing them are parallel lines. And then lesson summary. A translation carries segments onto segments of equal length. And a translation carries angles onto angles of equal measure. That's all for today. Nice work.